Record.
Hmm. Okay.
Hello
Okay.
everyone. My topic is behavior of big masonry houses during an earthquake. It's assignment number 3 submitted to Dr. Vasugi V, Assistant Professor, Senior SAE. Content of my assignment is the project Introduction to Construction Materials. Second, Capacity Design Concept. Third, Earthquake Resistant Design of Buildings. Fourth, Quality Control in Constructions. Introduction. In India, most non-urban buildings are made of masonry. In the plains, masonry is generally made of burnt clay bricks and cement mortar. However, in hilly areas, stone masonry with mud mortar is more prevalent, but in recent times it is being replaced with cement mortar. Masonry can carry load that causes compression, that is pressing together, but can hardly take load that causes tension, that is pulling apart. Concrete is another material that has been popularly used in building construction, particularly over the last 4 decades. Concrete is much stronger than masonry under compressive loads, but again its behavior in tension is poor. Both masonry and concrete are brittle and fail suddenly. It is a major drawback of concrete. Now coming to steel. Steel is used in masonry and concrete building as reinforcement bars of diameter ranging from 6 mm to 40 mm. Steel is a ductile material. This important property, ductility, enables steel bars to undergo large elongation before breaking. Concrete is used in a building along with steel reinforcement bars. This composite material is called reinforced cement concrete or simply reinforced concrete. The amount and the location of steel in a member should be such that the failure of the member is by steel reaching its strength in tension before concrete reaches its strength in compression. This type of failure is known as ductile failure. Now coming to the picture. First picture about is masonry in strong compression but weak is tension, and the second picture showing that a tensile strength of materials, showing that one about the brittle materials, and second is ductile material, and showing that the ductile materials can carry the large amount of force before failure, but the brittle element fails suddenly. Capacity design concept. What is capacity design concept? We will best explain by taking the example of the chain link. Let us make a chain with the links made of brittle and ductile materials, which is to be shown in the figure 3. Each of these links will feel just like the bars shown in the figure 2. Now hold the last link out of the chain and apply a force F. Since the same force F is being transferred through all the links, the force in each link is the same, that is F. As more and more force is applied, eventually the chain will break when the weakest link in it breaks. If the ductile link is in the weak one, then the chain will show large final elongation. Instead, if the brittle link is the weak one, the chain will fill and show some small final elongation. Therefore, if we want to have such a ductile chain, we have to make a ductile link to the weakest link. This is the figure which we explained now. The original chain with a ductile link and without a ductile link. And the ductile link, we will give the ductile link or weak point so that we want that failure at that occur at that point, not at all the points. The second is earthquake resistant designs of buildings. What is earthquake resistant designs of buildings? First point, buildings should be designed like the ductile chain. For example, consider a common urban residential apartment construction. The multi-story building made of reinforced concrete. It consists of horizontal and vertical members, namely beams and columns. The seismic inertial forces generated at the floor levels and transferred to the various beams and the columns to the ground. The correct building components need to be made ductile. The failure of a column can affect the stability of the whole building, but a failure of the beam causes localized effect. Therefore, it is better to make the beams to be ductile, weak links than the columns. This method of designing RASI buildings is called the strong column weak beam design methods, which will explain in the figure 4. And IS 13920/1993 for RC structures ensures that adequate ductility is provided in the member where damage is expected. This is a figure shows the concept of the strong column weak design method, which is shown in the figure that this is the strong column weak design methods. Reinforced concrete building design. The beam must be the weakest links and the columns. This can be achieved by appropriately sizing the members and providing a correct amount of steel reinforcement into them. Now going to the next slide. Now coming to quality control in the construction. The capacity of design concept in earthquake resistant design of a building will fail if the strength of the brittle link falls below their minimum assured values. The strength of brittle construction materials like masonry and concrete is highly sensitive to the quality of construction materials, workmanship, supervision, and construction method. Special care is needed in construction to ensure that elements meant to be ductile are indeed provided with feature which give adequate ductility. Strict adherence to the prescribed standards of construction materials and construction process is essential. Hence, regular testing of construction materials at qualified laboratories, periodic training of workmen at professional training houses, and on-site evaluation of the technical works are elements of the good quality control. Hence, I will be closing my like. Thank you. Start stopping my recording.